Hey, welcome. This video is on solving systems of linear equations, and we're going to use the elimination method. Sometimes we call it the elimination method, elimination by addition, or sometimes addition, simply just the addition method. So just kind of be aware of that. Okay, here are our rules. We can multiply a row by any number except 0. So you could take a row and multiply it by 5 or -2. It's still the same row, just looks different. And number 2, we can add rows together. So if you add 2 rows together, the result will still have the same solution as the other 2 equations. Our goal, when we add the 2 rows together, we want to get a variable to cancel when we add, either the x or the y. It doesn't matter. Right, so here's our first step. Number 1, write both equations in this form: ax plus by equals c. So you want the x first, the y second, and we don't want any fractions. So if you have any fractions, just get rid of them by multiplying each term by the LCD. So clear any fractions. Number 2, multiply one or both rows by a number so they will have the same coefficient but opposite sign. So you're trying to get the numbers in front of either x or y to be the same number but opposite sign. For instance, in front of the x, one of them would be a positive 12x and the other one would be a negative 12x. Or in front of y, one of them's a 5y and the other one's a negative 5y. Okay, step 3, add the 2 rows. When you add the 2 rows, one of the variables will cancel, and so we'll be able to solve for the remaining variable. So we'll either have x or y. Step 4, use that solution from step 3 to find the second variable. So whatever we got in step 3, if we got x, plug it into one of the other 2 rows and find y. If we got y, plug it in to find x. Okay, let's do it. Here's our first equation, 5x plus 7y equals 17, and 10x plus 7y equals 44. So we want the coefficients to be the same number but the opposite sign. You have 2 choices. You could either get rid of x or get rid of y. We'll talk about each case. If you want to get rid of x, well, it's kind of like finding the LCD for 5 and 10. You want them both to be the same number, so what's the LCD for 5 and 10? Yeah, 10. So LCD or LCM, least common multiple. LCD, least common denominator. So if we want the top row to be a 10, we have to multiply by 2. Actually a -2, so that they would cancel when you add. If we want to get rid of the y, well, we need the y in the top row to be a -7. So either choice is okay. I say we get rid of the y. So let's multiply the top row by -7. Now when you multiply the top row by -7, you got to multiply each term, even on the right, by -7. All right, let's do that. So that gives us -35x minus 7y equals -119. And then just recopy the second row or the bottom row below it. Okay, now we're going to add the 2 rows. So put a line on the bottom. The y's will cancel. So let's add the x's. A -35x and a +10x would be 25x. And 119 minus 44 is 75. Keep the sign of the larger. Okay, get x by itself, so divide by negative 25 on both sides. And you get x equals 3. Okay, so you can plug that x into either one of the two equations. Probably pick the easier one, right? So let's use the top row. So plug in 3 for x, and then work that out. Subtract 15 on both sides, that gives you y equals 2. We're done, we got our answer. You could do a check. I'm not going to show a check here, but remember, to do a check, you plug in the x and y into both equations to make sure it works out. Okay, here's the next problem. This one does not have the equations in the proper form, ax plus by equals c. So the top row, we're going to move the 5y over. So it'll be 3x plus 5y equals 25. Same thing in the bottom row. Add 4x to both sides. So there's our new equations. Okay, what are we going to get rid of? X or y? If we get rid of x, LCM for 3 and 4 would be 12. So we would have to multiply both rows by a number. You would have to multiply the top row by 4 and then the bottom row by negative 3. You can multiply the top row by a negative and the bottom row by a positive if you want. If we want to get rid of the y's, all we need to do is multiply the bottom row by negative 5. Let's do that. So multiply the bottom row by negative 5 all the way through. Top row, just bring it over. So negative 5 times 4x is negative 20x. Negative 5 times y is negative 5y. Negative 5 times 22 is negative 110. Add the two rows. The y's cancel. We got negative 17x equals negative 85. Divide both sides by negative 17. You get x equals 5. All right, let's plug it in. I'm going to use the top row again. You could use the bottom row. It's probably easier. It's definitely easier. All right, so let's use the top row. So 3 times 5 plus 5y equals 25. 3 times 5 is 15. Subtract 15 on both sides. Then divide by 5. And we got y equals 2. Okay, this one, we're going to have to multiply both rows. We could either get rid of the x or the y. The LCD for the x is 6. The LCM for the y is 12. 6 is a little bit smaller. However, the y's, they already have different signs. One's positive and one's negative, so that might be something to consider. All right, I think we should get rid of the y's. So we're going to multiply the top row by 3. That'll make the coefficient of the y a negative 12. And then we'll multiply the bottom row by 4. That'll make the coefficient of the bottom row a positive 12. Okay, so make sure you multiply 3 all the way through on the top row and 4 all the way through on the bottom row. The y's cancel. 17x equals 34 divided by 17, and we get x equals 2. So now we'll use the bottom row just because I used the top row last time. It doesn't matter. So plug in 2 for x, and then subtract 4 on both sides. So you get y equals 3. Okay, next example. 5x plus 8y equals negative 36, and 7x plus 6y equals negative 40. Well, we're going to have to multiply both rows by a number. We could either get rid of x or y. The LCM for the x is 35, so we would have to make them both into a 35, one positive and one negative. The y's, 8 and 6, LCM would be 24. If you use 48, it wouldn't be wrong, just have bigger numbers. But you would use 24, one positive, one negative. It doesn't really matter, it's totally your choice. I'm going to get rid of the x because we've been getting rid of the y, I believe. So I'm going to multiply the top row by negative 7 and the bottom row by positive 5. Again, that's just my preference. Alright, so if we multiply negative 7 on the top, we get negative 35x minus 56y equals positive 252. On the bottom is 35x plus 30y equals negative 200. Add the two rows. The x's cancel. And we get negative 26y equals positive 52 divided by negative 26 on both sides, negative 2. Let's plug it in. We'll plug it into the top row. Remember, this is y, so plug it in for y. So 5x plus 8 times negative 2 equals negative 36. 8 times negative 2 is negative 16. Add 16 to both sides. That gives us 5x equals negative 20. Divide by 5. X equals negative 4. So there's our answer. Negative 4, negative 2. Okay, we're all done with examples. I just want to show you a couple little last notes, okay? It says example, but it's not really an example. It's just a little bit of a problem. What happens if there's fractions in the problem? If there's fractions, then we have to clear the fractions. So here's an equation, 2/3 x plus 3/5 y equals 2. So if this is one of the rows, then we want to get rid of that 3 and 5 on the bottom. So we're going to find the LCM or LCD. What's our LCD? Right, 15. Remember that 2 on the right is 2 over 1. So we're going to multiply each term by the LCD, which is 15. So everybody gets a 15. Then you're going to reduce. So 3 goes into 15 5 times. 3 goes into itself once. I didn't put the 1 there. And then how many times does 5 go into 15? Right, 3 times. And then 2 and 15 on the very far right, the 2 is not in the denominator, so simply multiply 2 times 15. So now we get 10x plus 9y equals 30. So this is what we would obtain if we had an equation that had fractions. Maybe the other row is the same way, and then we use those two rows to get rid of either x or y. Okay, one more note. When we're adding rows, If both variables cancel and the constant is non-zero, then there is no solution because the lines are parallel. So if you get something like 0 equals 9, because the x's cancel and the y's cancel, and 0 does not equal 9, then the answer would be no solution. 0 doesn't equal 9, right? No solution means that the lines are parallel. They don't intersect. Okay, the other case is if both variables cancel and the constant is 0, then there are infinite solutions because the lines are the same line. So if you get 0 equals 0, that means there's infinite solutions. How could two lines intersecting give you infinite solutions? Well, if one is right on top of the other. So they're the same line. Okay, so every point on the line is a solution because they overlap. All right, that was it. Just wanted to go over those last two notes for you, and I'll see you here for the next video. Have a good day.